Now model is an empty ensemble right now. When we run this, model is an ensemble with a length of 1 ordered dictionary where the 0 and only index is the detection model. And given that we're only providing one set of weights, we will get out of this for loop. Now model is the ensemble, as I said, and we're going to iterate over the different modules within model. So let me open this and you can see how heavily nested this is. So model, modules, index 0 is detection model. If I scroll to the bottom, modules, and inside modules we have model, which is sequential. And then one more time, modules, and here are the modules for our neural net. Now we're going to iterate over these modules, and we're not using any of these, but if we find a SILU activation, our detect class or model, we will step into this. So let me scroll to the top first, and then let's start running this. Now the first module is Ensemble, which of course doesn't meet any of these requirements, so we'll step over this. Neither that one. The next module is detection model, and you don't see detection model here, but actually model is imported right here from models.yolo, and model is actually the detection model. And detection model is of course the class that we have. So if I go back to experimental, given that model is detection model, we're going to step into this. And now M is detection model, and we already have Inplace to true, but if we didn't, we would be setting up Inplace to true. As you can see here, Inplace was defined right here, and the value is true. And the Inplace operation is an operation that changes directly the content of the tensor without making a copy. So it replaces it in place. So that is properly set to true. Given that we're not in this condition, we'll step over that. Now, if we continue iterating over the modules, the next one is sequential. And of course, sequential is neither of these ones. So we'll step over that. And then the next one, we have the conf class here. Now conf is neither of these ones, so we'll step over that as well. And then the next one, well, now we have conf2d, again, neither of these ones, so we'll step over this as well. And then the next one here, now we have SILU. And this is because we're inside the activation of the first layer, essentially right here, inside SILU. So given that this is true, we're going to step inside this. Again, SILU has Inplace set to true, as you can see here and here. But if it didn't, it would override this value right here. And of course, we're not in detect, so we'll step over that. And then we'll continue iterating until all the SILU activation functions, as well as the AppSample module and the detect class have been updated. If I scroll here to the bottom, modules. So we'll have a SILU right here, another one here, multiple here, another one here. And then the next one we'll find is the AppSample. So let's iterate until we get there. And now M is the AppSample module, which is right here. And as you can see, it's asking if we don't have the attribute recompute scale factor, but we actually do, so nothing's going to happen here. If we didn't have it, this value will have been set to none right here. And then it will continue iterating over the different SILU activations until we get to the next AppSample. And again, it has this factor as well, so we don't have to change anything. And then we'll continue iterating over the different activations until we get to the detect class right here at the end. That meets this condition as well. Now we can take a peek here and check if detect, after we have stepped into this, if we have an instance of anchor grid, and if it's a list, anchor grid, and it's a list, as you can see here with the brackets. So we will never meet this condition. We will never step into this. If it wasn't a list, then this will create this anchor grid. And then once we're done iterating, we will get out of this for loop and return the model. Okay, so let me scroll to the top again. Now here we're checking if model has a length of 1. Well, our ensemble, we only have one model, the detection model. So model has a length of 1. So we'll step into this, and here we're just asking for the last index, which in our case is the last and only one, which is detection model. So when we run this, we'll return detection model to command.py. And then when we run this model, which right now doesn't exist, as you can see here, will be created, and it has the values of detection model with all the updates that we've done in our previous steps. Now here, we're checking to see what is the maximum between model.stride. Model.stride, this is in float 32, but we're going to convert it to an integer. What is the maximum between 32 and 32? Well, stride will be 32. And then here we're checking if we have model.module, and in that case return names, model.module. Well, we don't have that. So in that case, we return model.names, this dictionary. And we store it in the variables names right here. Now here, if we have FP16 set to true, we have it set to false. So we will not be applying the half operation, converting the tensors to float 16. Instead, we'll be converting them to float 32. We already did this operation earlier. And now model, which is right here, the detection model, will become self.model. When I run this, the variable self detect multi-backend now has the model, which is the detection model. Now, if we go back here, now we're checking class names. If names not in locals, well, we have names, so we'll step over that. And then if the first index of names is this, well, in our case is this label. So we will step over that as well, since we're not meeting this condition. And then here, we're assigning all variables to self. And then we return self, the detect multi-backend class, to the detect.py, where we call it from. And now here, you don't see model, but the moment we run this, the model variable has been created, and it has the detect multi-backend class with all the updated parameters. Now these parameters are going to be saved locally as well. So model.stride, 32 will be saved in the variable stride, model.names will be saved in names, and model.pt, the boolean true, will be saved here. And these variables have been created right here. We're going to step into the check image size function. And here we're checking that our image is divisible by the maximum number of strides, which is 32. So here we're checking if image size is an integer. Well, it's a list. So we'll step over this. And then here is converting it to a list. Well, it's already a list, so nothing there. And then here, for every index within the list, we're checking if the number is divisible. So we'll step into this make divisible function, which is right here at the bottom. And then here we're checking if we're going to divide by a tensor. Well, this is just an integer. So we'll step over this. And then here we're calculating the ceiling value between the 640 and that division. So 640 divided by 32, that is 20. That's already an integer. But if we weren't, we'd be returning the smallest integer greater than. You can see here the ceiling division, where it provides the upper bound integer. And then here we're multiplying that value, which is 20, by 32, again, to return the 640 size that we provide as input. In our case, nothing is changing because 640 is already divisible by 32. So we'll return that, and then we'll perform it for the other index, which is going to give us the same result. So new size is basically the same size as we had. Nothing changed there. Now here, if the new size was different from the original one, we will print a warning. In our case, it's the same, so no problems there. And then we return the new size, which is the same as the input that we already had. And then here, image size, 640, is going to override that, but we have the same values.